we're going to expand on the idea of arithmetic and geometric sequences and talk about series. And series are just a summation of a sequence. So we have a sequence, and if I want to add up all the terms, that becomes a series. So it's just literally putting the addition symbol between them and getting a final value as opposed to a list of sequences. And there's different ways. There's still a formula for each of them for arithmetic and geometric that we're going to want to use. But basically for our first one, we would want to add all the numbers from 1 to 1,000. And we don't want to do it by brute force. We want to kind of think about it. So one way to do it is to look at the first and the last terms, and then look at the second term and the second to last term, and then the third and the third to the last, and you're going to see that they all sum to 1,001. And so if they all sum to 1,001, I have some multiple of 1,001 that this whole series is going to add up to. And so what that looks like is this formula here, where I take n over 2 and I take t1 plus tn. So this is the first term and the last term, in this case 1 and 1,000, that's 1,001. And I don't have 1,000 of those because I'm taking two things to make each 1,001. So I'm going to take n over 2 times whatever these two things add up to. So for our above, it would be 500 times 1,001. And so if I had something down here where I want to send the first 40 terms of a sequence, I need the first term, I'm going to need that, and I'm going to need the 40th term, the last term. So to do that, I have a difference of -6, and so my nth term becomes 60 plus n minus 1 times -6. The 40th term, I plug in 40 for n, and I get 174, sorry, negative 174, and now I apply my formula where I take the first and the last, and then divide it by 2. So I would take 40 over 2, that's how many things I have, and then 60 plus negative minus 174, and that gives me my value, my sum of those terms. And we're not gonna check it by adding them all up, but we could, and we should get the same value as we move forward. Same idea for geometric. We add up a geometric sequence. This is the formula that we're going to use, where we have our first term times 1 minus our ratio over 1 minus our ratio to the power over 1 minus r. And so if we have some value here where we are going to need to determine it, we want to find the first 6 terms. First 16 terms. No, first 6 terms. We take our first term and then 1/2 to the 6th power, or 1 minus a negative 1/2. And we're going to get 10.5. We can just plug that in a calculator and go from there. Some geometric series are going to have infinite members, so it's going to basically just keep going forever and ever and ever, as noted with kind of our ellipsis here. And so we can see on this one, if we were to add this up, that it's just going to continue to grow, right? It's just getting bigger and bigger and bigger and bigger. Versus this one down here, which is getting smaller and smaller and smaller and smaller. This is said to diverge, it just goes up to infinity. This is said to converge as it gets to an actual number, an actual sum that we can find. So that one goes to infinity, this one goes to some number. And so if it's infinite, that term that was at the top, the 1 minus r to the n, is actually going to go away. We can look at kind of what's happening there. So from before, this was what we had, and we had this term r to the n power. But imagine that that's a fraction. So if r is less than 1, like a half, if you take it to infinity, basically you're getting 1 to an infinite power, which is 1 over infinity, which is said to go to 0. That basically drops out. That's a really, really, really small number. And so you're just left with that first term at the top. You're left with this piece because it's 1 minus nothing, which just gives you the t1 back. And so we use that to solve our series. Alright, so you're going to see something called sigma notation here. And sigma notation is a shorthand notation for summation. And basically what it means is that you're going to add up from the first term, from n equals 1 to n equals 10, this is the formula that you're going to use. So this is the same as saying I want to figure out 1 plus 3 plus 5, where these are our terms in here. So when n is 1, 2 times 1 is 2, minus 1 is 1. When n is 2, 2 times 2 is 4, minus 1 is 3. but this is just a shorthand notation to put this down. So we're going to use that on the next sheet here to kind of solve problems. But again, it looks weird, but it's just notational stuff. So this is saying add up from n equals 1 to 25 for this sequence. So this is arithmetic, and we know that's T1, T25 is 73, and then we just use the arithmetic sum formula and we get our value. Right. This one is geometric, so we're going to know T1, and then we have T5, that's our last term, and we plug them in and to our formula, and then that's it, we get some number. This one down here, as we get our values, that's A1 is 6, it's going to infinity, and we have to think about, is my R value going to diverge or converge? Well, in this case, it's bigger than 1, so it's going to diverge, so there's no value that we can get for that. This one, again, is infinite, but my R value is less than 1, so it's going to converge, and it converges with the formula of our first term, right, over 1 minus our R value, so it's even easier than the 1 up here, because we don't have to worry about that 1 minus R to the n power. All right, on the next ones, we're trying to rewrite these in sigma notation. This is geometric, and so I have my geometric formula. I just need to know my starting term, and then I need to know what is the n value that makes this thing stop. And so I could write them out, and that's going to be 5, so that's my sigma notation. And then on the last one, this is plus 6, so it's arithmetic. I know I start at 1, I need to know what I end. That is going to give me a value of n equals 17, and you're done.